Andres, where should we go now?
Okay. So, oh, right. Actually, just a very quick question.
Of course.
So, here when you're graphing them as paramet or when you're using parametric equations to graph them, you it's always x equals a secant t. Is that and then y equals tangent b tangent t?
You're asking me this.
Yeah. Is that just how it always is?
That that might be. I couldn't say for sure because your your parametric equations don't really come into play here unless I would need to see an example of something that you're trying to work through, because usually it's like use these parametric equations to write it in rectangular form, which is y equals x form is rectangular form.
Yeah. All right. So there's uh, number six has parametric equations in because yeah, number six has
Okay. Okay, there it is. Meteor. Okay, just show the meteor. Okay. All right. So I just read it to myself. I should have read it out loud. The part that we care about here is where it says suppose that t equals minus 1.4, the position x and y is those things. So they're giving you t to find a. Is that okay?
yeah.
All right. General hyper is a hyperbola with general equations x equals a. I mean, I don't. This is where I really feel like I need a little more to go on because this is just me coming in blind. But they're giving you t, but t is normally defined in radians. Like you can calculate if you know that x is 29.418 and you know that t is minus 1.4. I mean, this is totally allowable. This is totally a calculated problem where a is 29.418 over secant minus 1.4. It could be that they want you to take these right here and make these into rectangular form first.
Okay.
Let me check an online resource to see if I can give you a for sure answer on this. If you know, I mean, I would certainly appreciate you giving me a heads up um, on this.
Uh, you use the so you would use I think you would use the Pythagorean theory identities to
Right. So
right.
the one that we can use here is 1 plus secant squared equals tangent squared. Right? Is that kind of what you're thinking?
Yeah.
Uh, yeah. So the usually you use cosine squared theta plus sine squared theta equals 1, but here they want you to use 1 plus, I think it's secant squared. I need to check my reference sheet. It's the second one that you generally have to remember, so it's like less less common to pull it up. I'm just pulling up myself to make sure. Yeah, tangent squared plus 1, or 1 plus tangent squared theta equals secant squared theta. So here you've got, you want to solve for secant. So x over a equals secant t, which means when you square it, you get x squared over a squared equals secant squared t. So that's over here, x squared over a squared. And y over b is equal to tangent t. So then it's y squared over b squared equals tangent squared t. So we got 1 plus y squared over b squared. Okay. Oh, and to answer your questions, yeah, I mean, it does appear that that this is the form of the hyperbola, because you move this over and you get, or you would say x squared over a squared minus y squared over b squared equals 1. That's the equation of a hyperbola centered at 0, 0.
Yeah.
So more generally or more conceptually, maybe that's what you're asking is like it's like x minus h equals a secant t. That's the full one, and y minus k equals b tangent t. That's got the full
Yeah. Okay.
displacement on it.
I think. Yeah.
So I mean here, if you put in x and y, you can't find a and b because you need another point.
Mm.
So I think you have to find a the way that I described here, and same thing with b. Uh, over tangent minus 1.4 cosine minus 1.4 radians. Okay, yeah, I guess that works. So I'm asking all the people I'm helping now. I mean, if give me any feedback you can. Like, if there's anything that's not working for you, I want to correct it right away. I don't want to waste your time by not doing what you need most. So let me have it. Is there anything you need me to do differently to make this better for you?
No, this makes sense. Thank you.
Okay.
Well. um, I'd like to ask about Directrix is uh, just finding them in general. I Yeah, I'm alarmingly bad at
Okay.
that.
Sure. Uh, are you in pre-calculus?
Yeah.
Okay. They're starting with this.
Yeah.
It's crazy.
Oh, oh right. At my school, for some reason, it's a like last year I took one semester of trig, and then the second semester was uh, the beginning of pre-calc, and then
Okay.
this semester is the end of it. So,
Okay. So you'll do a little calculus at the end.
yeah.
Okay. This is my favorite reference sheet for conic sections. I would have this printed out. Your book might have one, but this is one page. It's right there. So you asked about the directrix.
Yeah.
Okay. So that's associated with parabolas only. Um, I hope that's what you're asking for.
Yeah.
And
Yeah.
I can okay, so I can show you graphically what it is. So imagine there is a parabola y equals x squared. Yay. Okay, one of those things right here. And there's a place here where particle comes in, bounces through that. Particle comes in, bounces off, goes through that point. Okay, that's the focus, right? That point is called the focus. I mean, that's what's going on. So it's a distance. It's some distance from the vertex. Now, the directrix is this horizontal line that is the same different distance away. In this case, it's a horizontal line.
Okay.
This is the directrix. Now, when I was learning this, I probably just memorized the equations. That's probably the best way to do it. But if you take a step back, you realize that you don't have to memorize anything, because if it's y equals x squared, the directrix is going to be the same distance. You realize this is y equals the number down here, and you don't have to worry about it. It's whatever this is. This is h, and if you go up, you're adding p, and if you go down, you're going h minus p, which is what we get here. You're not seeing my screen, are you? I apologize.
No, I'm not, but I understand what you're saying.
Yeah, I gotta fix that. Okay, so the idea is that these beams come in and they go through the focus. Beams come in, they go through the focus. It essentially focuses it, right? That's the word's reasonable, and it's a distance from the vertex. Well, you go down the same distance. That's the directrix. And I was trying to show you that you don't have to remember the formula. You can sort of do it on the fly here. If you have a parabola that opens up that way, um, depending on wherever this point is, wherever this this is now k. Um, minus P, and this is now, if you go the other way, it's a vertical line. This is the directrix. It's X equals a number because it's obviously going up and down. There is some physical meaning to the directrix. These conic sections are extremely useful in astronomy and satellites and trying to get things to work that we just hope works. I don't actually know what the directrix is for, but I got a guy. There's a guy that works for me. He's a big astronomy guy. I'll ask him tomorrow, and I'll tell you because I'm kind of curious too. But that's conceptually what it is.
All right.
It's the same distance p away from the vertex.
Thank you. I think those are all the real questions that I have. And then besides that, would you mind working through some problems with me?
Of course. Do you have specific ones, or do you want me to come up with them?
Uh, you can come up with them. Yeah, sure.
Okay.
I don't really want to just go at it'd be wrong to go into the homework with you here. You know?
Wrong for you, wrong for me, because I'm here to help you. And if you need help doing your homework, I mean, or get it guiding you through it, especially like even ones where you don't have access to the solutions. I mean, there's no judgment here because I mean, I've been where you are, where I'm like, how do I get this done? So it's up to you. We have not done a parabola yet, so I think I'd like to start with that.
Okay.
So there's really two types of questions that you're going to be given. The first is I give you the equation, and you tell me all the stuff about it.
Yeah. All right.
Okay, and then I call this the forwards problem. The backwards problem, you can probably figure it out, is I tell you a bunch of stuff. I like basically this comes here. I give you the characteristics, and you create the equation. This is what we did in that 6A that you asked me to do. There's sort of variations in some of these, so I'll try to give that to you. Let's say we had y squared minus 4y plus 8 equals, let's do it this way, minus 4x equals 0. So this is a variation on the first one where it's like, tell me all the stuff about it. And if they're going to give you a parabola, they're going to give it to you in y squared because then it opens left or right rather than up or down, which is what you're used to. How comfortable are you completing the square?
I am pretty comfortable.
Okay, so y squared minus 4y, I'm going to move these two terms to the other side of the equation. So it's going to be 4x minus 8. I need you to complete the square and tell me what goes down here in this binomial and what goes on this right hand side. Give you like 30 seconds to do that, please.
All right, so it'd be y minus 2 squared, right?
Yes.
All right, and then on the other side it'd be minus 4, right?
Okay, so this is what I heard. What goes in this box right here? Like if you were to
Oh,
expand this binomial, what goes there in that position?
so that would be plus 4.
Okay, so you have to be fair. So you do that.
Oh, right. Okay, yeah.
So this becomes 4x minus 4 on the right hand side here. If you have access to this this cheat sheet, this reference sheet, whatever you want to call it, the correct formula right below it is y minus the reference formula 4p x minus h. So I want you to tell me what h, k, and p are for this particular problem, please.
Okay. So H would be 1, K would be 2, P would be 1.
I didn't hear you about p.
Oh, 1.
Good. Okay. Now p doesn't have to be a whole number. It can be fraction. It can be whatever it is. You set whatever's out here. So I should have factored this for you, but you set whatever's out here equal to 4p, and it just so happened that p is 1. So if you have H, K, and P, you can find all this other stuff. Okay. The vertex, the focus, the directrix, direction of opening, all that stuff. Okay. What's your plan for learning the equations? Do you plan to memorize? Do you plan to have it out on next to you because your teacher allows that? Other option C. What's your plan?
I'll probably memorize them.
Okay. Um, are you familiar with what's called it's called a brain dump.
No.
It's a test taking strategy. So when you learned your unit circle, you may have even been asked to do it like in a timed environment. Well, a brain
Yeah.
dump is where at the beginning of the test, you write down everything, everything that you don't want to remember.
Okay.
And I'm suggesting that as a strategy here because kind of a lot like the unit circle, you may not get these problems in order. You might get a hyperbola, then a parabola, and an ellipse, and you don't really know. And it's very easy to miss points because you're not using the right equation. You get the wrong form. So that's just an aside there. All right, let's look at a hyperbola. Is that okay?
Yeah, that'd be good. Thank you.
Hyperbolas are they're the ones nobody likes. They do have a minus in there, so you kind of get a little bit of some help on that. So we're going to go x squared. I'm making one up here in my graph, so I'll tell you. I'll write it down in a moment. All right. How do they usually give these to you? Okay. I need to look up some questions so that way I can give you some decent ones here. All right, so here is one that I found. It's kind of I call it like a level 1 question. It tells you that the vertices, and it is a hyperbola, like I am telling you that, are at 1 comma 0, plus or minus 1 comma 0, and the asymptote is at y equals plus or minus 5x. So we can draw a picture here. The graph paper here helps a lot. So the vertices are at 1, 0, great, and then minus 1, 0, and then plus y equals 5x, and then y equals minus 5x. So let's go up 5. We got that point there, that point there. So have you seen this box that they sometimes draw?
Yeah. Yeah.
Okay, so I'm gonna draw this box, and we know that there's the line that goes like this, and there's the line that goes like this, which I didn't even get through there, and then the vertices are there, so we have an idea that it looks something like this and like this. Is that okay?
Yeah.
All right. If you've got a reference sheet up, can you tell me whether this is the vertical transverse axis, the horizontal transverse axis, or you don't know?
Would it be the horizontal one? Because
How
Trevor.
do you how do you know that? I mean, are you guessing? Or are you just because there's 50% chance,
Yeah. Yeah.
right? You know?
Transverse goes through the to hyperbola, right?
You talking about like it goes through this way?
Yeah. Like.
If that's how you want to remember it, that is, I mean, you got the correct answer here. So it's x minus h squared over a squared minus y minus k squared over b squared equals 1. So um, you know the center. Center is at the origin.
Mm.
Okay, so this reduces to x squared over a squared minus y squared over b squared equals 1. You probably have to show some work for that, like at least like this for your instructor. Now, what are you going to do to find this? The missing values here, because if you put in this point 1 comma 0, what does that allow you to find? A or B?
A.
Matt, I'm sorry.
Yeah, it helps you find A, right?
It helps you find A because y is 0, so this whole term goes away. Okay, so you feel real good about that, and then you go put in minus 1 0 and you realize, oh, they're really the same, they don't help you. Okay, but you can find A. Did you agree?
Yeah.
If you have your reference sheet, that's why they give you the asymptotes here. There is a equation, a formula for this. Like, I'm not big on like, oh, let's learn a bunch of equations, but in this case, I just tell everybody the same thing. You just got to learn these things. There's not really a good workaround at this point. So y equals, because k is 0 and h is 0, plus or minus b over a x. So this tells you that b over a is 5. B over a has to equal 5. So by finding a, you can find b.
Okay. All right.
Is
So
that so let's do that. I actually want you to do that. I'm going to take 60 seconds here, and you go ahead and find those values, and I will work through it again here shortly.
wouldn't wouldn't A just be 1 and B just be 5 then?
Yes, yes. So b is
5.
fantastic. So the best way to learn, in my opinion, and I've got sort of this other project I'm working on. You want one either just like this, I'm guessing, or you want kind of the related question but not the same thing. Is that reasonable here?
Yeah.
Okay. So let's say, see if I can pull it up here. Let's say this time I tell you that the vertices are at 0 comma plus or minus 3, and the directrix, or the asymptotes, is y equals 1 over 9 plus or minus 1 over 9x.
Okay.
So what I'd like you to do, and I'm gonna work it out here. I mean, this is not real suited to me thinking you're gonna do this, but I would like you to try working this out. It's the vertical transverse one.
Mm.
So give yourself, a minute or two and see if you can work this out here for me. Give me
So
the equation.
just find HK
And
AB.
A B, yeah.
All right. Okay. Oh wait. Nope. No, no, no.
Hopefully I gave you one that works. I didn't actually. I'm not sure that these. I mean, should work, but there's always a chance.
So, oh, right, there's the other equation. I forgot about that. It's A 3 and B 9.
I'm not sure. So I'm gonna work it out here. So we know that this is centered at the origin. So it's y squared over a squared minus x squared over b squared equals 1. I'm gonna use one pointer or the other to find a. So we know that when y is 3, this is 0 squared over b squared equals 1. So a is 3. And that's 9 over a squared equals 1. So 9 equals a squared. So a is equal to 3. Is that okay?
Yeah.
All right. Uh, to find x, you don't have enough information. But here, I mean, this is like a test-taking strategy thing. Your teacher, I mean, they wouldn't give you this if they weren't like, hey, you really need to use this. So you have to remember, like, well, why is that there? I mean, you may not know how to use it, but you should at least be like, okay, I probably need to use it. Not sure how. So in this case, the asymptotic equation, the asymptotes, it's different. It's y equals k plus or minus a over b x minus h. So this is y equals plus or minus a over b x. Well, you know that 1 over 9 has to equal a over b. Did you find a? Yeah, a is 3. A is 3. We found that down here. So if a is 3, 1 over 9 equals 3 over b. So we can find that b is 27.
Yeah, okay, that makes sense.
You're okay. So what you showed me initially with the textbook questions, like I don't know if you've done this yet, but you really, to learn this stuff, you really got to go back to problems where they give you the equation and you find the characteristics. And you want to do one parabola, you want to do one ellipse, and you want to do one hyperbola. And that's the only way you can know that you do this stuff, because all the problems that you want me to work with here are the backwards problems, the ones where we're like using the behavior, the characteristics to figure out what it is. So I got an ellipse problem here. I want to pull up here for us to look at. So we're going to move away from the origin. A lot of the problems that we've done so far have been at the origin. Those are kind of boring and simplistic, but they're still hard, but you might see something else in the exam, so we might as well take a look at those. So this problem, I'm telling you, it's an ellipse problem. I don't have to, because of the way that the language would be given here. It says that the major vertical axis has a length of 10. The minor axis has a length of 4. And we know that the center is at -2, 3. So that gives you h and k right away. All right. But the question is, and we talked about this earlier, okay, so it's x minus h squared, y minus k squared, there's a plus, equals 1. Well, which one is it? Well, if you recall from from earlier, in the ellipse, a squared equals b squared plus c squared. That means that a has to be bigger than b. So you have a choice. Either the major axis, well, it's given here. It tells you that this is 2a and this is 2b.
Yeah.
So a is 5, b is 2, and you know which one to put it under, I guess. Let me see if this problem gave any more information. I just sort of summarized it here. You know that, I'm sorry, so there's another part to here. A is always bigger. I'm not sure how they expect you to know that A is 5 and which one it goes under. Is it?
Oh, isn't it? We're gonna go under.
It does. It said vertical. Vertical. That's what I missed. Okay. I didn't see that. So they do give you the vertical, which tells you that, okay, it's b squared and a squared. Because if they told you that the major horizontal axis was 10, then you know that these switch.
Yeah.
Could switch. Okay. All right. Let's try another one here. This one is slightly more difficult. So this one, and there's a lot of variations. They're like, if I give you an ellipse problem where I'm working backwards, I have to give you like one piece of information and then a second piece of information. And there's different overlaps between them. So it's not really practical to do them all, but you should at least realize that you got to use all the given information. So for this one, the endpoints are at 7, 9 and 7, 3. And the other endpoints are at 5, 6 and 9, 6. Now this one actually words it slightly differently, but if you have some paper handy, it's worth sketching here so that you can decide, is it a vertical major or which one's the major one? Is it the vertical one or the horizontal? Is it clear what I'm asking you to do?
Yeah. It'd be a
Okay.
vertical major, right?
So the distance here vertically is 6,
Yeah.
and the distance horizontally here is 4. So we know that this is a vertical one. All right, so I want you to try to write the equation given this information. You can obtain the vertex from this information here, but I don't want to just tell you. I'm sorry, the center. I keep calling it vertex. Center and vertex are kind of the same thing. But I'd like you to spend 60 seconds here trying to come up with the equation for this. It's very similar to the last one.
All right. So
Do you have a final answer for me?
yes. All right. Sorry. Excuse me. So what I got is so x minus 7 squared
Good.
over 2 squared
Perfect.
plus y minus 6 squared over 3 squared equals 1.
I really like how you wrote that with two square and 3 square. That's my preference too. A and B can be fractions, so just keep that in mind as well. All right, let's do a what is it? I don't have that. Okay, I'm gonna do a completing the square here problem. 4x squared plus 25y squared. Actually, let me change this one to a negative, make that a negative there, minus 24x plus 100y plus 36 equals 0. I might have to change a sign here or there, but actually let me graph this one real quick so I can make sure that it's what I want. Y squared. Yeah, this one actually works. Okay. So this is a completing the square question. It would say, the question would be like, what type of conic section is it? That's kind of the most basic thing. And then it could ask for the characteristics of it, the whatever it is, it might, depending on what it is. So really what they're asking you to do is to complete the square in both x and y. So to do this, and it sounds like you're going to take more math. Is that reasonable to assume?
Yeah.
Like you might take some in college.
Yeah.
Okay, great. They give you this question. You have to complete the square all the time in math classes in college, and they expect you to do it very quickly. So this is a good exercise for you to do. Here, we're going to pull out the 4. So it's going to be 4x squared minus 6x. I call it leave a space, minus 25, y squared minus 4y, leave a space, equals minus 36. All right, do you recall what goes in this position based on the formula for completing the square?
Yeah.
Okay, what goes here?
9.
9, but it's 4 times 9. So 4 times 9 is what goes up here.
Yes.
So we're going to put that here. Here, what goes in this position here?
It'd be 4, but up top.
But you have to multiply by
Negative 100. Yeah.
yeah, so it becomes minus 100 over here. All right, so this becomes 4x minus 3 squared minus 25, y minus 2 squared equals negative 100. And what do you know what to do from this position? Because this is not right over here, but it does change. It change like there's many ways you could do this. What do you see here? What are you?
I don't know.
Okay, so the minus here tells you that it's a hyperbola.
Yeah.
But if you don't really recognize that this is negative over here, you'll write the wrong kind because you divide everything by minus 100. So you clear minus 100 over here. So you get, you switch the signs and everything. So the y comes first. Now it's going to be y minus 2 squared. It's really a 4 on the bottom. So that's 2 squared. It's 1/4. Minus x minus 3 squared. 4 over 100 is 25, so we're going to write 5 squared equals 1. Now it's in the correct form.
Okay.
You have to be able to complete the square. In Calc 3, they ask you the equation of a sphere, and you have to be able to complete the square. It's on ASU, U of A's, first exam in Calc 3. So it's like you just got to, you never get away from this stuff.
All
right, so we are out of time. I'm going to send this to you by email, the PDF notes. The video takes about a day to process because there's a Zoom delay, and then I upload it to YouTube privately, and then I send you the link to that. But you'll have the PDF of the notes. Is it okay if I just show you a couple of the things that might be useful for you on my website? It'll take 1 minute or less. Is that okay?
I would appreciate it.
Okay. All right. So where the heck is this? Okay, let's get back to that. All right, so I'm at my website. You found me today by going to Meet with Matthew, and you likely clicked on private tutoring. I also offer what's called a virtual homework help. It's the exact same thing we just did, except like I'll only answer one question. I do that on Mondays at 7 and Wednesdays at 4. You just click here and go through the, you click on the time, it'll send you the Zoom information. It's the kind of thing where if you're just stuck on one question, I'd be happy to help. If you are planning to take the SAT or ACT, I know that that's sort of up in the air. I developed a bunch of really quality questions that are different than what you've seen in practice books. And I post the question, and then at some point, I'm going to require the email for the solution. But currently, you can just see it here. It's a completely worked out solution, so you can see how to do it. So if you're thinking about that, it's like a good practice to like just do one a day. If you're a student that I work with regularly, I can just send you more if you want as a courtesy. So that was all I wanted to share with you.
All right. Yeah. Thank you.
You're welcome. I hope you got a lot out of this, and I look forward to helping you again.
All right. Thank you. Have a good night.
You too. Bye now.